All right. Welcome to week 2 of advanced web programming. I don't even know the name of this course. Basically the mean stack. So thank you for submitting your lab ones. For those of you who missed quiz 1, just remember to look at your announcements on Blackboard, where I'll say when things are due. Don't worry, it's just 1%. Now I'll give you an opportunity to double your mark for this week's lab, so you can make up for it. A couple of things that I noticed in your labs, just real quick. Let me see if I can pull up open file. Actually, no, let me go to relating to Markdown. So when you were writing your code, some of you may have noticed you tried to do one dot here and then another dot here, but it didn't change from 1 to 2. That's because I forgot to mention that make sure you tab the content in between the ones. If this stuff is indented to the left, then this one doesn't work. The 1, 1, 1 doesn't change to 1, 2, 3. First thing I want to say. Second thing I want to say real quick. Yes, you can. The question is, can you integrate Git with VS Code? Yes, you can. Here is an icon for that, source control. You can initialize a repository, and I'll maybe get into that a little later, but the answer is yes, you can. Okay, so today's class, I want you to pull up this, my slides that I made yesterday and the last minute today. And so if you go into Blackboard, you will see a link that I just posted on the announcements for the pre-class to-dos. And you can get the same exact slides that I'm looking at here. So here, so this one right here, this link right here, under pre-class to-dos, this one here. You're with me, because there are some links there that I want you to click on eventually. Okay, so as I said last class, I know most of you haven't had a JavaScript class here at Georgian yet. So I'm going to try to make up a semester's worth for this class here. It'll be, I think today's class will be a whirlwind for you. Try to keep up. So to do today, we are going to take a historical look from JavaScript when it first started to now. We are going to look at some benefits of Node. I'm going to answer some of your questions. Like a lot of your questions for the lab one was, why is it asynchronous? I don't get it. I don't get the non-blocking, why it's unpredictable. By the time we get to this event loop, hopefully you'll understand why. And then fourthly, learn some of the latest updates to the JavaScript language called ES6 or ESX+. So throughout this class, I'm going to be displaying some of your questions that you submitted to me in the form of in lab 1. So here are some 3 questions that I got from all of you. I won't be answering all your questions today, just some, and I'll answer the other questions later. So here are some questions. Why are we learning JavaScript? The language is outdated in modern web. Is JavaScript useful for today? I haven't touched web development in my co-ops. How can I keep up? Are we going to learn which tech companies use JavaScript in their work? So I use this as a framework to begin today's class, just to give you a lay of the land where JavaScript stands today. Okay? Here we go. Slide. Most popular language on GitHub. There are some. This is a survey that GitHub posted. I want you to write down on a piece of paper, or if you don't have a piece of paper, just open up your local notepad here. Type in 1, 2, 3, 4, 5. Let's take a game here. You write down what you think the top 5 most popular languages are on GitHub. I'll give you 1 minute, and then we'll take a look at the answers. 30 seconds. All right, let's try this out. So if you click on the image itself, I actually linked it to the actual survey that GitHub produced last year. It'll take you to this octoverse.github.com. So this is the result of their survey. If you scroll down, you'll see that same graph. You'll see the answers. There we go. 15 most popular languages on GitHub. What's number 1? JavaScript. Okay, next slide. Here's another survey. 2018 Developer Skills Report. This is a neat report showing you what languages you need to know for employers. So let me just scroll down to the here. Okay, so this one, the first one here is developers are learning the languages employers are looking for most. So the question is, which languages do employers look for by industry? Number 1, what is that? Number 2. Okay, let's scroll down one more. The biggest gap in knowledge is with JavaScript frameworks. Which frameworks do employers need and versus developers know? All of this, Angular, Node, React, that's all JavaScript. Next slide. Stack Overflow, every year they produce a survey. This is where you get a lot of your answers from, right? So, most popular technologies, programming, scripting, and markup languages. What's number 1? For the 6th year in a row, JavaScript is the most commonly programmed. So what happened? What happened to this idea that JavaScript is an outdated toy language? What happened? We'll get into that. Such is the past, in the past few years, such is the case of JavaScript that you get articles like this. Let's click on the image, which takes you to the website. JavaScript is eating the world. In case you haven't heard the news, JavaScript and Node.js are single-handedly eating the world of software. Here are some companies that are switching to Node, for example. Netflix, PayPal, Uber, IBM, Microsoft, just to name a few. Also, JavaScript is responsible for animation, such as this. All of this is created through a JavaScript library called GreenSock. And GreenSock is the #1 animation library that professional web designers use. GreenSock, yeah. So that's, and if let's look at the code. If I click on this, it'll take you to the code. CSS is nothing, but here's the JavaScript code. So they're using a JavaScript library. You can see here, they're using all kinds of different things. It's all JavaScript. Also, it's dealing with things like augmented reality, virtual reality. This, for example, is all the line of code you need. You put that in an index.html page and run it. Notice this, all you're using is .js files, .js, and you come up with something like this. So I pasted the code here, same code, exact code. Augmented reality. There you go. In fact, as of last week, every year Google has their I/O conference. This was dated May 9th. This has just happened last week. Let's just take a few. Let's just take a glance at a few minutes of this, just to see what they have to say.
Building the future web with modern JavaScript. My name is Matthias. We work on the V8 that's used in Google Chrome and in other embedders such as Node.js and Electron, for example.
JavaScript started out as the scripting language of the web, and to this day, it's still a crucial piece of that technology. But today, JavaScript's reach extends far beyond the web to the entire surrounding platform.
So if we take a step back from just V8 and Chrome, you can see that JavaScript allows you to build engaging web experiences that work in a wide variety of browsers. And with Node.js, JavaScript can be used to build powerful command line tools, servers, and other applications. React Native enables building cross-platform mobile apps also using JavaScript. With Electron, JavaScript and other web technologies can be used to build cross-platform desktop apps.
Over there. Some of you have looked at, may have used some of this, so you obviously know Skype. How many of you use this one, GitHub Desktop? Okay. Okay, you all use this, yes? What is this? Visual Studio Code. That's what I'd ask you to download and use. Who knows this one? Slack. What's this one? Atom. What do these desktop apps have in common? They were all built with HTML, CSS, and JavaScript and Node using Electron.js. That's what people just mentioned. So yes, you can actually make desktop apps using web technology. That's how far we've come. Let's take a look at their website real quick. So here's Electron.js. Here it is. Build cross-platform desktop apps with JavaScript. You basically npm their package, and you just another article I saw, JavaScript conquered the web. Now it's taking over desktop. So that's from Wired magazine. Again, they talk about use of Electron here. Electron. It's not JavaScript is not only just web. It's now server. It's now desktop. You even got this. I saw this. Node bots. Node-powered robots. Let me just take. What did I put here? Oh, okay. So this guy's using JavaScript to power different robots, different things like that. What else do we got here? Well, Internet of Things and robotics. Let's see what link did I have here. Oh, that's too quiet. Never mind. So, and not only that, so this course is about the mean stack, but JavaScript is changing so fast. We got a new stack called Jamstack, which I think is going to be huge. So the J, anyone? So the J stands for JavaScript, APIs, and the M stands for actually the same markdown format that you use for Lab 1. That's basically what the M stands for. People are now writing their content in Markdown, compiling it so that it turns into HTML tags and uploading it. And through the use of JavaScript and APIs, boom, you got your web page. So that's how fast things change. Okay, so to answer the first few questions, rather than being outdated, JavaScript has matured and changed in the last several years to be the most popular, hottest language in modern web development. The question about I can't keep up, whatever, I personally accept the fact that it is impossible to keep up with the JavaScript ecosystem. I don't know if you've read that link I sent for the pre-class to-dos, where I asked you to watch that YouTube video and read that funny article. That funny article, it should give you a sense of I can't keep up. But that's okay. I want you to develop that lifelong mindset of just learning all the time, that you are a professional student, career-wise. Just to let you know, this is a podcast that I personally listen to Syntax FM. If you click on that, you will see a podcast that Wes Boss and Scott Talisky, you may have heard of them. And every week they talk about different topics that's related to the latest web development stuff that you should know. So check that out. And the third question, which tech companies use JavaScript? As we saw, Netflix, PayPal, Uber, Microsoft, LinkedIn, Yahoo, Mozilla, Groupon, GoDaddy, Abit. And there's a really neat story about here on NASA. I don't know if if that's included here in that link I gave you. Top 10 companies that use Node in production. Let me just see if NASA was there. It was, yeah. If you ever have time, click this, and it's kind of scary. So what happened was the astronaut, there was water forming in his helmet, and he was like about to drown, and they didn't know why, and so they switched to Node. It's really interesting. Okay, so the next few questions from Lab 1. Some of you asked this. Why non-blocking JS do not do what we anticipate? Why we have to run again and again the following code? Why is JavaScript an asynchronous language? What is callback function? Okay, Okay, before I move on, any questions so far, comments? Before we move on, so today's class will be basically set by set by set. Any comments, feedback? No? Okay, cool. So when I saw these questions, it made me realize, okay, let's just get to the foundations of asynchronous callbacks and what's happening under the hood. So right now, everyone create an index.html page. So open up your Visual Studio Code, open up new file, and here's a real neat trick. Visual Studio Code, if you don't already know, already comes with Emmet installed. Show of hands who knows what Emmet is and have used it, or Emmet, no? So check it out. I'm going to type in exclamation mark, and then I'm going to press the tab key. Oh, sorry, not yet, not yet, not yet. I have to save this first. So Control S to save. Let me save it. Oh, where should I save it? I'll save it under desktop. Yeah, just desktop. Okay. I'll call it index.html. All right, so I've saved it as an HTML page. Now, because Visual Studio Code now knows it's an HTML page, watch what happens. If I say Shift-1 to give the exclamation mark, and then press the tab key, boom. By the way, let me go back to that syntax link. Let me go back to that syntax link. Back to that, there's this one podcast that really opened my eyes to Visual Studio Code, and it's this. Yeah, this one, episode 12. Why is everyone switching to VS Code? Check it out. Anyways, even Sublime, when you know Sublime users are switching, it's VS Code rocks. Okay, so let's type in this. So, I mean, you could copy and paste it if you want. You could copy and paste it from a slide if you want to be fast. That's fine. And so okay, here, where do you put that in your HTML page? Put in the what? In between which tags? Oh. You put in the script tags, right? Script tags. Script tags, paste it. There you go. Okay. One of the questions I remember you asking was, what is the overall purpose of JavaScript? When JavaScript was invented, the sole purpose of JavaScript was so that you could run code in the browser. Okay, so only later through Node was it then transferred to being in a server. But so here we got this. Let us run this in the browser. So how do you do that? You just open up a tab, open up that file under which I saved in desktop, index. Now to see it, you have to view the console tab. How do you view the console tab? Right click, inspect is one way, and then click on console tab. So it already ran, so I didn't have a chance to see my code. But let's refresh and see it again. Refresh. Hi, hello. 2 seconds later, you see world. Did you see that? Let me try it again. Refresh. Hi, hello. 2 seconds later, world appears. Y'all got that? So what is happening here? What is this link I have here? Oh, right. Okay. I'm sorry, what? How did I open up so quickly? Oh, like in the browser, you mean? Oh, I just said, open up a new tab. That's usually blank. Here's a new tab, right? Then I say Control O, up, and whatever web page I'm looking for. So I saved it under my desktop and I clicked it. That's how you open up a web page, right? Locally. Control Shift J. Let me try that. I've never tried that. Cool. I like that. I love that shortcut. I shall keep that forever. Thank you. So Control O opens up my index. Control Shift J. Console. Love it. What's your name? Dali? How do you spell that? My class? Okay, I have to look at my class. Daniel. Oh, okay. Oh, so you're the one that remembers that question then. Okay. Cool. Yeah, when I saw that question, I said, gotta set them straight. Okay. Okay, so what is the question I have for you is this. what is the fundamental difference between this code and, for example, if you're to do this in PHP, where you say echo hi, sleep for 2 seconds, echo hello, kind of thing. You know, what is the fundamental difference? The answer, yeah. Yeah, so in PHP, it's synchronous, meaning just like a drive-through through Tim Hortons, you have to wait for the car ahead of you to finish before you can order. In PHP, you would have to wait 2 seconds here before you actually get to the next car. Whereas in JavaScript, it serves the first customer. It serves a long, this is going to be a long, it's going to take some time to do this. So it delegates to the kitchen staff, if you will, and then it serves the next customer right away. So that's why you see hi and hello first, then 2 seconds later, you see the world. Okay, we will get into that. I actually made a diagram to illustrate this, which I thought was a brilliant algae. We'll see if it is. So here is an example of synchronous. Okay, so I have faked synchronicity, if you will, in JavaScript. Okay, so I'm going to show you the web page here. So what it's going to do is, and this is what happens in PHP, for example. You know, you get some kind of database request. After that's done, then it goes to the next line. You wait. After it's done, here, you wait. After it's done, then you can do the rest. Okay, so I've done a fake sample of that here. Now, the question, the observation I want you to have as I run this, before I click run, is when I run it, I want you to notice I can't do anything else if I try, even if I try, because it's synchronous. So here we go. Ready? Run. Oh, wait, hold on. Let me see the console log. You want to see the console log first, because I had some messages in there. Okay, here we go. Run. Click to the link. I can't go to Google. Click to the drawer. I can't do anything. Now it does it, right? Because it's finished. That's synchronous. Do we want that as a web experience in the browser? That's the answer to why JavaScript is asynchronous and not synchronous. Because all web pages would be useless. You know, it would be like your UI experience would be like that, where you can't click anything else. You don't want that. So the solution for that is asynchronicity, or whatever. And we'll get deeper into that. Just a quick show of hands, who actually saw the YouTube video that I posted? Anyone? It's okay if you didn't. If you have a chance, please watch that. Here is my drawing that I did yesterday that I thought was a brilliant analogy related to Tim Hortons. Yes?
It only showed when we were coding. It didn't show anything of what we learned before we started coding. You know, like things that we did, as well as talking about some of the subjects that we're going to be learning throughout the semester.
Must be in the break. We'll see. I'll get it back to you. All right, Tim Hortons async analogy. So here are 3 different customers, okay? And the rule is, actually, let me, I had my notes for this slide somewhere else. So let me get my second monitor handy so I can remember what to say. There it is. Okay, so the rule is this. Here are the desk rules. The worker at the desk, when they receive, your order, they can only do fast tasks. What's a fast task? Coffee. Slow tasks are making sandwiches. If the worker at the desk receives a slow task, they immediately delegate it to the kitchen. That's the rule. Once an order is done, they call out whatever was in the quote and they give the food. That's what's in the desk rules. Here are the rules for the kitchen. When an order is received from the desk, when it's delegated from the desk, take time to make it right. Once it's done, then place the food and ticket, or the quotes, in this line up here. So this is where I'm going to depart from the regular Tim Hortons. Imagine this done line up is one of those conveyor belts that has like a hook that you can put your ticket or a seat on, and has a conveyor belt where you can put the food on, and it kind of keeps on going. Okay, so just imagine that. So this here is the turnstile, and the rule for this is this: when the desk is not doing anything, then look at this done line up and send the food and the ticket to the desk. Okay, so let's imagine this happening now. So let's, let me get back here. I'm going to pretend, and it's going to give me 5 minutes or a couple of minutes to do this. So let's pretend this is coffee.log double double. Okay, and that will take the place of this so that I could move it around later. Let's get another one going. Notepad, Panini, Bert. Okay, so okay. Another one going. Coffee, log. Okay, so here are our 3 customers and orders. Here we go. So what happens? So the first customer comes in to the desk. Question: is this a fast task? Yes. So the rule is make it yourself and then call it out. So the desk worker makes it real quick. Then once it's done, they call out the quote, double double, and they give the food. So once they say double double, that's here. That's the sequence. This is the sequence of events, right? That's the first thing you'll see in the console.log. It's double double. Next one. Question: is this a fast task? No. It is a slow task. Therefore, what does the desk do? It delegates to the kitchen so that the desk is now free to get the next customer right away. Okay. So that's an important step right there. So, yeah, oh, shoot, what happened just now? Oh, crap. Did I just, what happened to all my others? Sorry. Okay, so now the desk can serve the next customer. Is this a fast task? Yes. Therefore, black serves already. So that's why in your console log you see double double first, then black. This panini takes time. Now, once it is done, because it took a lot of time to do, then they place the food in the done lineup here. Okay, they can't put it here. They have to put it here. So the rule for this is if there's nothing happening at the desk, then take the first thing in the queue in the done lineup, put it here. Now the worker says, Albert, done. What I just showed you is an analogy of what's happening under the hood in your browser. That's why JavaScript is asynchronous. However, let me give you the true names. Let me reveal to you what's the true names of what's happening here. So this desk is actually called the call stack. Who here has heard of V8? V8 is the engine that Chrome uses to run JavaScript. Oh, the drink. Yeah, no. Yeah. Well, maybe they were drinking that as they were creating the engine. I don't know. Okay, so the true name for the kitchen is the web APIs. Okay, remember JavaScript's overall purpose at the beginning was to run in the browser. So not only do you have V8 that runs JavaScript code that's single-threaded, that only does one thing at a time, but you have your browser that also has these different APIs. So when you do something long, for example, fetching a request, JSON request from a third-party computer server, that's an example. The command fetch falls under this web APIs, which the browser handles. Okay. This done lineup, the true name of that, is called the callback queue. Okay, this is where all the callbacks happen, right? So, for example, everything in here, for example, Panini, Albert, usually you'd have a callback here, right? So all of these are kind of callback-ish. And then the true name for this turnstile is called the event loop. And then here, sequence is just the console log. Okay. So question: what methods in JavaScript land take a really long time? Answer: set timeout, which you just saw. Fetching data, JSON data. Things to do with DOM manipulation, reading files in Node, for example. Those are all examples of things that take a long time. Okay. Now, one thing I did notice, this is where my analogy breaks down. Here, what I said, Panini Albert, that isn't quite right. Okay, because this is where you'd have the callback function, function. And that's the reason for that, for a callback there, is because you don't want to say Albert right away, right? When Panini comes to the desk, you don't want to say Albert right away. You want to say that after it's done. So that's why you wrap it in a function callback. Okay. Any questions on that? So what we're going to watch now, let me just close all my, oh, that's why. Can I just do this? Close all windows. Great. Okay, so now what we're going to watch now is, this is the same YouTube video I asked you to watch earlier. We're just going to watch 5 minutes of it. This is the most crucial part of his talk, but if you have a chance to watch this whole talk, it's brilliant.
This console.log high. That cues the console.log for the future somehow. So then we skip straight on to So asynchronous callbacks with regards to the stack we saw before, how does this work? So let's run the code. Console.log high, set timeout. Okay, what's going to happen here? We know that console.log there doesn't run immediately. It's going to run in 5 seconds time. We can't push that console.log onto the stack. So somehow it just disappears. We don't have like
that's what it's delegated to the kitchen.
Describing this yet, but we'll come to it. We log JSON clear, and then 5 seconds later, somehow magically console.log there appears on the stack. How does that happen? And this is basically where the event loop comes in, and concurrency. Right? So I've been kind of partially lying to you and telling you that JavaScript can only do one thing at a time. That is true. JavaScript, the runtime, can only do one thing at a time. It can't make an AJAX request while you're doing other code. It can't do a set timeout while you're doing other code. The reason we can do things concurrently is that the browser is more than just the runtime. So remember this diagram. The JavaScript runtime can do one thing at a time, but the browser gives us these other things, right? It gives us these web APIs. These are effectively threads that you can't access like threads. You can just like make calls to. And those pieces of the browser are where this concurrency kicks in. If you're a backend person, this diagram looks basically identical for Node, except instead of web APIs, we have C++ APIs, right? And the threading and all that stuff is hidden from you by being run in like C++ land. Okay, so now that we have this picture, let's see how this code runs in this kind of more full picture of what a browser looks like. So, same as before. Run the code, console.log high to console. Simple. Now we can see what happens when we call set timeout. So when we call set timeout, we pass this callback function and a delay to the set timeout call. Now set timeout is an API provided to us by the browser. Remember I said it doesn't live like in the V8 source. It's like extra stuff we get in the environment that we're running the JavaScript runtime in. So effectively we kick off the timer, right? And like the browser kicks off the timer for you. And now it's going to handle the countdown for you, right? So that means that our set timeout call itself is now complete, so we can pull off the stack. JSON clear. So now we've got this timer in the web API, which 5 seconds later is going to complete. Now the web API can't just like start modifying your code, right? It can't just like chuck stuff onto the stack when it's ready, because if it did, it would like just appear randomly in the middle of your code. So this is where the task queue or the callback queue kicks in. So basically, any of the web APIs, when they're done, they push your callback onto the task queue. And finally, we get to the event loop. The title of the talk is what the heck is the event loop. The event loop is like the simplest little piece in this whole equation, and it has one very simple job. The event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the queue and pushes it onto the stack, which effectively runs it, right? So here we can see that now the stack is clear. There's a callback on the task queue. So the event loop runs. It says, oh, I get to do something here. Pushes the callback back onto the stack. Now remember, the stack is like JavaScript land, right? This is back inside V8. So the callback appears on the stack and gets run. Also the left there, and we're done. Does that make sense?
Cool.
So now we can,
All right, so hopefully that opened, did that shed some light, open some eyes perhaps? Yes? That help? Cool. So let's go back to last week about the non-blocking. Now, hopefully, once you see this again, it'll make sense. This is the asynchronous code that we did last week. So, this read file, this could take some time. And you may see the title, the console log food first, in this case, followed by console log drinks. And then maybe you might see the list of food and the list of drinks after that. Or, depending how long these take, maybe you'll see some other order. Okay, because this is not set timeout. Set timeout was, set timeout 2 seconds is a minimum guaranteed. It'll wait 2 seconds, but there's no guarantee how long this takes. This could take very quick. This could take very long. I don't know. Depends on the operating system, what the operating system thinks. So that's why you can't predict the order of this. Maybe it'll say food, and then maybe it'll say this list, and then maybe it'll say this list, and then it really depends. But if these are really long, like food.txt, now obviously I think you would see console log food first, console log drinks next, and then depending how short these things are, the shorter of the two usually should be next, but it's not guaranteed. Because maybe the computer decides to work on the really long one for more time than it ought to. Who knows? Okay. What did I want to say here? So the question about what are callbacks. So I'm attempting to address that here, and I think the first thing you need to know is unlike other languages, you can actually pass functions. That's called first citizens. If you ever see that term first citizen, that's what it means, and that's a very powerful programming technique. So here is an example. You have your variable name, you set it to Joe, no problem. You have a function that you pass an argument, and the parameter, you just console log it. Cool. So obviously, hello name would say Joe. And now let's just quickly run that. So if I copy that code, let me try your shortcut. Control-Shift-J. Beautiful. Let me clear this. Control-Alt to clear that. Let me paste in that JavaScript code. Now, the reason I can do this, for example, there it is. I press enter and the console log Joe. Now, for some of you that may be thinking, what just happened? You're entering code inside the console. Remember, the whole overall purpose of JavaScript is to run in the browser. So when you're opening up the console, it's just as if you were to type in your JavaScript code into your file in VS Code and just copy and paste that code and put it into the console. That's all you're doing, kind of thing. Okay. Now, okay, there's no problem with that, but watch what happens. I can actually change this to be not just a string, but to be a function. So here's a function with that same name. And notice here, this hello is a function, but this name is a function. So I'm actually passing a function in a function. Okay. Let's see what happens if we run that. I'm going to make one slight change. Instead of console log, I'll return it. Let's see what happens here. Okay, I ran it. What did it output here? It outputted a function, namely this. So this, when I say this, hello name, it gives me its value, and its value is a function. Okay, interesting. Now here's the really cool thing about JavaScript. Okay, let's assign that to something. So var, a, which is a terrible name for something, and then give it a name of, pass it the same thing. Okay, so now the variable a has whatever that was, and to prove it, I could say console log a, or because I'm already in the console, I'll just say a. There you go. Okay, cool. Can I run it? So a is a function. Can I run that function using a? How? JavaScript, you put the brackets. That pair of brackets signifies run it. This is what makes JavaScript very powerful, most above other languages. This technique, passing functions in functions. Okay, so to answer your questions, why not blocking JS does not do what we anticipate because we are using asynchronous operations. And by the way, when the question, why did we have to run again and again the following code? We only ran that code again and again just to prove to ourselves that the output of the non-blocking JS file is unpredictable. Question, why is JavaScript an asynchronous language? Answer, because JavaScript uses a call stack that lives in V8. It uses web APIs that live in the browser. It uses a callback queue and an event loop, which you just learned. So now that you know what's under the hood, hopefully that'll make sense when you do JavaScript code. What is a callback function? Callback functions are just normal JavaScript functions that is called when an asynchronous operation is finished. Cool. Any questions so far before we move on? Questions, comments? All right, so some of you asked some of this. So what did Ryan Dahl invent that revolutionized JavaScript? Is this whole course based on JavaScript? Is this course a full stack course? Let me answer those really fast. So what did Ryan Dahl invented? What's the answer? Node. In 2009, Ryan Dahl invented Node. Is this whole course based on JavaScript? Yes, it's a full stack course. You got JavaScript in the browser or the client, and JavaScript in the server. What are the benefits of Node? Where and why we use Node? Okay, let's move on to the next slide. This quote came from Node.js Foundation. With Node.js being used in 98% of Fortune 500 companies regularly, why Node? So this is where you come in. I've put a link here on 9 famous Node apps. I want you to read that article, and I'm going to ask you in 5 minutes what the main benefits are for Node. So go ahead and click that link, and you will see quotes from different companies. For example, here is PayPal, and the question is, why did they choose Node? Oops. The question is, why did they choose Node? And they give a quote right here. So go through that article, and in 5 minutes time, I'll ask you to just give me one word of why they chose it. Okay? And there's a few different words that I want to hear. Okay? I'll give you 5 minutes for that. All right, we could. All right, so you've read some of the reasons for why they switched. Give me one word, in one word, why some companies switch to Node. Go. Scalability, yes. Anything else? Speed, yes. Anything else? Lightweight, okay. Anything else? Say it again. Unification of the team, so the whole front end team, back end team know the JavaScript. That's good. Anything else? Say it again. Less code. Yeah. I'm looking for, yeah. There, that's what I'm looking for. Less hardware. Sorry to scare you there. Yes, that's right. Less hardware, because Node can handle so many requests concurrently so fast. It doesn't need that many computer space. Yeah.
A memory footprint, and it was advantageous to use the same language on the server side as well as the client side.
Yes, that was someone else's point, I think. Right. Cool. Very good. Very good. Okay. You are about to meet the inventor of Node right now. His name is Ryan Dahl. Here he is. We are going to watch 2 minutes from 2:36 to 4:33, and also from 12:28. So we're just going to basically watch 4 minutes of his talk. So this is when he first created it. It was first presented in 2011, but he created it, I think, in 2009. So let's watch it from 2:36 to 4:33.
Then you get Node, which is a command line thing. It's not a GUI. It's not IDE. It's something. It's like Python, right? You type it in your command line. If you type it without arguments, you kind of get this weird prompt, and you can type JavaScript in there. Okay, so Node is a bunch of sugar on top of a very complex virtual machine written by Google called V8. V8 is the JavaScript engine inside of Chrome. It is a beast. Okay, it's a huge, very high performance virtual machine written by very smart people. That is not what Node is. Node is a set of libraries on top of V8. Okay, that takes uses its greatness to do networking things. And the emphasis is on networking. It's somehow a general purpose thing, but the focus is on doing networking correctly. And so it does it in a slightly weird way that I hope to demonstrate with a couple of examples. But first, let me just point out that, yes, you do have a REPL, and you can type, function add AB, return A plus B, and add two numbers, right? So that works. There's a global variable in Node. So in browser JavaScript, you have this window variable that's like this global thing that somehow ties you to your site. Well, that's because you're in the DOM. You have a window that you're playing with. In Node, you're not associated with a browser. So you don't have this window object, you have this process.
I'll stop there. So the important takeaway there is Ryan, he took V8, which was in Chrome in the browser, and he made it so that it now works on the server. And yeah, let's watch this one here, 12:28 to 14:12.
And then you have to create an HTTP server, which you do with create server. And that thing gets a callback. So looks something like that. So that callback is executed every time a request comes into the server. That makes sense? So, which is slightly different than every time a connection is made to the server. So I'll just call the server S. And we have to bind to a port. So I'm just going to choose port 8000, right? Because I'm not root, so I can't bind to lower number of ports. So here's the hello world thing. You write a header, which is 200 OK, content type text plain. Okay, looks good. You guys all see that, by the way? Okay. And then you end the response. And we'll just say, hello world. So that's your body. So headers and body. So let's try that out. So I'm going to run web server. Okay, not exiting. There's stuff to be done, right? It's listening on a port. So let me go back to my thing here. And now I'm going to curl HTTP localhost or 8000. And I get hello world. Okay, excellent. So we wrote a little web server. I think we can even do it here. You can do it there too. Okay, so we can hit hello world. Excellent.
And that's just all I want to show you for that. Okay, so the big idea again is JavaScript is now living both in the browser and it also can live in the server. So when we look at our code that we wrote last week with server.js, let's take a second look at that. I want you to try to go back to your code, run it, and this is the challenge, not challenge, but this is what I want to try to do. Try console logging the request. So obviously you have this request, and I was asked last week, what is that request? Where does that come from? I want you to try to console logging that request in Node. So take your code last week, run your server.js again. So node server. Actually, before you run that, you should edit it. So inside this create server function, maybe after this, maybe the first line after this squiggly bracket, enter a new line and say console log request. See what happens. If you weren't here last week or you don't have the code, I will attempt to do it. So here's the code that we did last week. The only change I made was this line right here, console.log request. So if we run it, let's go into all right. So you get the server running on port 3000. Okay, so if I use my, actually, hold on, was it port 3000 or is it 4000? Oh, I have 4000 here. Yours may be different. So if I go to my browser, open up localhost 4000, because that's what I had. Enter. As soon as I press enter, I get that. But more importantly, I go back to here. There. Do you see all that output? Let me maximize my DOS. All this information that came from just me going to localhost 4000. All of this information came with that. So response, the question last week when I was, what is response? Where did that come from? That came from you. And this is all the data that came with it. A lot of data. Right, cool. All right. What else did I have here? So you may have noticed in the video, Ryan Dahl, he used this something called curl command. Let me show you real quick. This is just the neat to know. You don't have to know this, but it's really neat. So I configured my terminal here in VS Code. To get your terminal within VS Code, you can say control backtick, and you can get this. Now, I configured it to use my git bash instead of the DOS prompt. So that means I can use curl. So I think it's running. So if I say localhost 4000, I should get there, our first node page. That's exactly what I sent, right? Here, our first node page. FYI, if I said curl -I stands for inspect, the headers. Look, here's the headers. So HTTP 200 OK, right? 200, that came from here. 200. It has some other stuff that you never see when you go visit any web page. But that's just neat to know. Okay. So answers. What did Ryan know? Oh, Node. Yes, this is a full stack course. And what are the benefits of Node? Scalability, flexibility, less hardware, so it's cheaper costs. Same language empowers the team. Exchanging data via JSON is more efficient, right? Because if data, I don't know if that was mentioned in the article, but if your data is basically a JavaScript object already, pretty much, then there's no time needed to change formats. Any questions or comments before we move on to the next set? Okay, let me just see what's ahead of here. Few more slides and then we'll take a break. So you asked, what is the difference between let and const? Now I'm learning that var is not to be used after 2015. What's up with that? Is a JavaScript object property equivalent to a Java class instance variable, a JS function equivalent to a Java method? Who asked that one? That was a good one. Is he here? I'm going to say yes and no to that one. I'm going to say for now, as a beginner to JavaScript, yes, you can think that. But later on, you'll see that the JavaScript function can do more powerful things, has superpowers. Okay, and then why does JavaScript require the use of the command prompt console? Let me answer that real quick. So as you heard from Ryan Dahl, Node is just a command prompt thing. And that's how you should kind of think of it. So it doesn't need, you don't need to console log to something. It's just very convenient to see the output, right? That's all. I guess the real answer to this is because JavaScript is a runtime. And in runtimes, you could just do, what you did, 1 + 2, and it outputs 3 right away. So we're just going to get into the early years of JavaScript. We're just going to watch 4 minutes of how JavaScript came to be. Okay, so from 423 to 827, I think. Look at it from this one here. Oh, hold on, I think I had a link somewhere.
They wanted it to work was like HyperCard. HyperCard was
this was on the old Apple.
By Bill Atkinson at Apple, which made Macintosh programming really easy. You could have a bunch of buttons and attach simple scripts to them and cause things to happen. So they wanted to do something similar to that instead of to a stack of cards, as Atkinson had done.
Let me set the context before I resume. So when Netscape, who remembers Netscape? Okay, when Netscape came into being, the decision was we want some kind of coding language in the browser so you can do neat things. And the question is what to put.
A web page.
And they wanted to emulate this.
They hired this guy, Randy Mike, that's been at Silicon Graphics, brilliant guy. In his interview, he said he wanted to write a scheme interpreter. They said, that's great, that's just what we want. After they hired him, they found out what scheme was. They said, no, you can't do that. People won't like that. Do something that looks more like Visual Basic for Java, something people like. So he did that. So he combined elements of 3 languages. Java, because he was told he had to, and 2 really interesting languages, 2 failed languages, in the sense that they got 0 market acceptance, but 2 brilliant languages and 2 highly influential languages. So they're known not much to the general programming community, but they're very well known to program language designers. And it was a surprising choice to take features from those 2 languages. Scheme was a dialect of Lisp, which was inspired by Carl Hewitt's actor model. Brilliant language, probably the best implementation of functions in any language we've ever seen. Self was a brilliant language that came out of Xerox PARC originally. It was taking Smalltalk and stripping it down to a simpler language in order to make it go faster. And it turned out in making it simpler, they actually made it profoundly better. That project then moved to Sun Labs. So for a time, Sun was supporting research into both Java and Self. And at some point, Sun made a decision and killed one of them. In my opinion, they killed the wrong one. Self was clearly the better language. Brennan took elements of all 3 of these languages and a little bit of his own and put them together into a new language that was called LiveScript. And LiveScript was going to become one of the key technologies for Netscape going forward. It was going to be in Netscape Navigator 2, so you could have LiveScript applications running on the client side and on the server side. Netscape's Livewire server had server-side JavaScript in it. This was back in '95. So JavaScript was there from the very beginning. It was very clear that at the time that there was a lot of excitement about Java and the Netscape browser, and Sun and Netscape decided they needed to work together against Microsoft, because if they didn't join forces, Microsoft could play them off against each other and they both lose. And the biggest point of contention in that arrangement was what to do with LiveScript. Sun's position was, well, we'll put Java into the Netscape browser, we'll kill LiveScript, and that'll be that. And Netscape said no, that they really believed in the hypercard-like functionality. They wanted a simpler programming model in order to capture a much larger group of programmers. And so there was an impasse, and the relationship almost broke up when I think Mark Andreessen, I haven't been able to document this, but people have told me Mark Andreessen, maybe as a joke, suggested, let's change the name to JavaScript. And it worked. Except that Sun claimed ownership of the trademark. Even though they had nothing to do with the language, they tried to kill the language. They said, we own the trademark. We'll give you a license to use the trademark. It's a great, an exclusive license. Only we can call it JavaScript, that's fine.
Yes. Let me just a little bit of the history of it. So the big point takeaway is that Brendan Eich was hired to create JavaScript, and he created JavaScript in 10 days using a mixture of different languages. Some of you, I don't know if you caught what he said, but Scheme was a derivative of another language called Lisp. I tried using Lisp back in New York University. I almost failed that class. Now, one thing I remember the professor saying that day was, during that class, he said, when he's displaying this column diluted line of code in Lisp, all I remember him saying was this. He said, and that's power. Which to me, I interpreted, some languages are more powerful than others. Okay. Just a quick history. So you may have heard ECMAScript, or for example, when I said to you last week, ES6. ES stands for ECMAScript. What is ECMAScript? Think of ECMAScript as the design or the template that JavaScript should be based off. So there is a committee called TC39, and they are in charge of ECMAScript. And whatever they decide, ECMAScript, how it should be, JavaScript will follow that. Okay, so really you could think of JavaScript and ECMAScript as synonyms. However, just to let you know, I know if some of you have heard of Flash. What did Flash use for the code? It was called ActionScript. Remember that? ActionScript is also part of ECMAScript. So ActionScript and JavaScript were very similar. Anyways, so the big takeaway from this slide is this one here. This is the big one, ES6, which was created in 2015. This is when it changed the web development community on its head. Before that, it was getting interesting with Ajax, but as soon as ES6 hit, that's when things started the ball rolling to making JavaScript eating the world. So yeah, just letting you know that. And every year, by the way, there's always additions to the language, new additions to the language. So this is, unlike other languages, this language every year will constantly change for the better, I think. And again, the committee involved, they're called TC39. They're like the gods of JavaScript, as you were. And this is just a FYI. If you yourself, you want a change in JavaScript, this is how you do it. You go through stage 0, you put in your specification. If it goes through, it goes to stage 1. The committee, they debate about it. If it's successful, it goes to stage 2, and once it reaches stage 3, it's pretty much going to be in the next Chrome or next whatever. Stage 3 and 4, you're basically in 3 and 4, you're basically guaranteed that that new feature will be added to the next version of Chrome or whatever browser. Okay. That is it for now. Break time, I'll give you 15 minutes. So the next half of the class will be all coding the new ES6. So getting to know ES6.
The fact that it's been on sleep mode for most of you. Just give me a moment to refresh. Basically, after a long internet search, I found the right link for your video, but it didn't cover what we were talking about before we started coding in class. So when I was trying to save the quiz, there wasn't a lot of material, which would explain how I got 1 out of 5 on that quiz. Yeah, I was trying to look for the information we discussed prior to our coding class in the video, but I couldn't find it.
Well, all the questions I took, all the questions I made up for the quiz, actually, whatever we did in class. So if you couldn't find it,
Yeah, so basically I went to weekly learning. Okay, so this wasn't there, so I checked announcements. And then, okay, so if I click on here now. Okay, so let's see, is you setting up your plans or something? Okay, this is a coder. Last time it was somebody else.
oh, you know what? I know what happened. Originally, when I posted on Blackboard,
Yeah.
I posted the wrong.
Yeah, and then when I looked at this video, I couldn't find anything except the coding. So
Did you want another chance to
yeah, I have the chance to get a higher mark on quiz number 1 and to see if there's links to whatever study information we went through. Because I'm not sure if we have any PowerPoints, whatever, but
Okay.
mention all those facts like about Node.js, something raw, as well as different types of languages.
No problem.
Yeah, it was before and after we did that quiz thing on Kahoots. Yeah, so I'm just trying to clarify. That's where it's at. Because I know I could have done better on the quiz if I could have had easy access to STEM material. Even though there wasn't a lot of STEM material.
Okay.
Thank you. For all those examples, I was only able to complete this part. I didn't get a chance to type it in the bottom.
Oh, okay, so you just have to. And here you can just copy and paste the code from the slide. You know, just paste it.
So how do I access the slide?
Go back to
Here.
and then in slide, I got it right there.
Okay, so click. So instead of PowerPoint, this is type of slide presentation.
So copy that.
Okay. Okay, thank you.
See what happens. So look at it in the browser.
It's not pasting.
Copy.
Copy. Copy. I have no idea. And plus there's some sort of narration. Temperature regression. This is the Microsoft Edge.
I'm not sure why.
Okay, copy. Paste. Try Control V. Okay, let me try typing in into Notepad, see if that works. Yeah, I don't know. Sometimes my things glitch for some weird, bizarre reason. Yeah, or maybe you could just, yeah. Right, I'll just try to type from scratch.
of course, because I'm not viewing.
Right. What happened? Like, was someone else supposed?
No, I think I just offered and I said, yeah.
Oh, true.
Yeah, so I have yet to complete the course. I just have to keep one week ahead of you.
Oh, there.
In our teacher. Yeah, I put it all under announcements. So afterwards announcements.
You also experiencing factoring.
We're up there.
So you just download their I feel like our break needs to be a little longer. Is that true? 5 more minutes? Say it again, sorry. Okay. All right. Okay.
That's pretty Oh, yeah, yeah. It almost opens down the thing so good in the television and it's great magic. Right. It's like important library.
All right, I think we'll get started. A question I was asked over the break was, what do you use to make your slides? Yeah. So I came across this link on Twitter sometime last year. It's called webslides.tv. And I didn't have time to look at it until I started teaching. So I said, okay, let's try this instead of PowerPoint. So it gives you the functionality of the arrow keys already. All you have to do is just change the content. For example, you could use a template like Apple's. Here's Apple's example. And you just change the content. And because it's web-based, you could embed YouTube videos. You can do different things that you normally can't do with PowerPoint, right? Okay, so this latter half of class will be all about you coding the new JavaScript way, ES6 plus way. So what I'm going to show you is a bunch of new things you need to learn. I'll show you how to do it, and then you get to play with it for 5-10 minutes, and then we move on to the next thing. And we do that for the remainder of the class, okay? Before we get to do that, I'm going to show you just a sample of what you're up against. Here you go. 5 minutes.
You want to create a stunning website. I've already done it with Wix.
With Wix.
Hey, Wes Boss here. I wanted to do sort of a fun code along, and that
show of hands. Who here uses LinkedIn? Anyone? All right.
I've got all these LinkedIn notifications because I never go on LinkedIn, but I don't want to have to click accept like a sucker, and also I don't want to accept the recruiters because they just send me emails about exciting opportunities. So what I want to do is let's programmatically do it, and if this says recruit or anything like that, then we don't click accept. Otherwise, I don't care. Everyone else can come on in the party. So how do we do that? Well, first of all, we need to accept all of these, and what I did is I inspected this li, and it has a class of invite-card. So I'm going to say document.query selector all.invite-card, and that gives me a huge node list of every single person that has invited. Now that is not yet an array, so we can use ES6 spread to convert that to a real array here. So that does everything that I want. Now I just want to loop over them. So I'm going to bring my code in here just so it's a little bit saner to loop over. So we are going to use .forEach on it, and for each card, we want to do, let's just console log card, make sure that's still working. Paste that in, good. I'm getting a console log of each an individual card. Now we need to make a couple variables, one for this actual thing right here. So what is that? That's a paragraph with the class of headline. So I will say const headline equals card.query selector, because now we actually just want to look inside of that specific card for the headline, and then I'm going to call that text content on it. Why? Because I just want the text inside of it, not the actual element. So let's see the headline. Great. Now I'm getting like what people are: front-end engineer, software engineer. Now that we have that, we also need the buttons so that we can click them. We'll say const accept equals card.query selector. Same thing. We all want to look for what is there's a class on here, bt-invite set. Let's just double check that we are also getting the accept button working. Looks like it. Good. Now I need to filter these buttons for anything that says recruit. So we will say if headline.match recruit, and we want to just make it global in case insensitive. And the reason I say recruit is because it could be recruitment, recruiter, and recruit will just match them all. If they are, then console log, nah. And maybe we'll also grab their name as well. Const name equals card.query selector. Name equals query selector. What is their name in? Oh, it's an A with class of name. Text content. Nah, name looks a little fishy to me. Okay, we'll get up a little bit of emoji up here. That one looks good. A couple of them. Else, also log. Name looks cool. Let them in. A couple emojis to make it nice and fun. Cool. So now let's do a dry run on this. Hey, what do we got here? Looks cool, looks cool, looks cool. Let's go to the first one, recruiter right here. Again, recruitment and talent acquisition specialist. Looks a little fishy to me, not something I can let on in. Cool. So now that our filters are working properly, we can go ahead and I'm just going to click the button accept. So I should end up with a whole bunch of recruiters here that have not yet accepted. So I'm going to say accept, click. And that will force or trigger a click on that actual element. I'm going to run it again one last time. Whoa! All right, looks like I accepted like 60 people all at once. What's left? There's a whole bunch of recruiters. I could go through this again, and I could select the deny button and programmatically click that as well. Actually, let's go ahead and do that real quick here. You see that all of them are still popping up. 12. There's a couple left here. BTN invite declined. And then we get say decline. Programmatically click that. If I run it again, gone. Everybody is done. I'm off to the races. So that's kind of a fun little code along. You get to learn a little bit about the spread. You can learn a little bit for each. We use an arrow function here. We selected the things. We triggered a click. A bunch of.
All right, cool. Cool. So what we're going to do is we're going to learn some of what he just used, feature by feature. So again, we're going to take it slow. We'll learn one thing at a time. You have 5-10 minutes to play with it on your own. And so you just get a grasp on it, and then we'll move on to the next feature. Okay. So the first feature I want to talk about is JavaScript objects. So open up your text editor. Let's grab a new file, open up a new file. Save this as something on the desktop, I guess, index.html. Yeah, I'll replace what I had. Exclamation mark tab. I got that. Great. All right, so the first thing I want you to do is type this out, or I guess you could just copy and paste if you want. So just type all of this out. I think it's better for you to type it out. Just, I don't know, I have a theory that if you type it out, you kind of learn better that way instead of just copying and pasting. That's just me though. So here's my index.html. I've copied and pasted, or for you, hopefully just typed it out, this. So what I want to say about this is how to declare an object in JavaScript. It's with the curly brackets. Okay. So if you say console.log data.college, you should get Georgian, because the way to access these values on the right-hand side is through whatever you declared it, dot whatever the property is. So here on the left-hand side, that's called property. Here on the right-hand side, that's called value. Sometimes it's called key value pair. So just try that out. Let's try that out. Run it. So desktop index.html, open that up. Right click. Oh, no, I don't want to. I'm just say Control Shift J. Thanks, Daniel. And then you got Georgian. There you go. Right. So everyone got that? Everyone's playing with that? Okay, cool. That's very simple. Here's what I want you to do. I added a little thing here. Try adding a nested object called program that has two properties, code and year, then try displaying those values. So let me show you how that's done. So after this berry, you want a comma, okay? And then we're going to add another property called program, colon. But instead of typing the value, the single value, we're going to type curly bracket. Okay, so this will be a nested object within an object. And then within here, it'll be the same as if you did college Georgian, except with whatever you want. So I think I said, what's your program code? So say code, and then string, say Copa, I think, is yours. Then whatever you want, year, I don't know what year we're in, say 2017 to 2018, whatever. Save that. Now modify your console log data dot whatever. Change that data dot whatever to what you think it should be in order to access your program code. So I'll give you a few minutes for that. 1 minute for that. You're already done. Try accessing the year. Try accessing just the program. All right, so you may have come across this. So your code might have said something like this. You said, in order to access the code, you might have said console log data dot what? What's the answer? Yeah. Program dot code. Yes. Save that. Open it up. Was I keep on doing the inspect. I want to do the control shift. There it is, COPA. I did it here as well. Let me see here. So I just randomly took my control shift J here, and I just put the data in here, object. So data.program. If I just do data.program, what do I get? What is that called? What's that called with curly brackets? Object. That's what we're learning here, right? So you just made an object, you just output an object, and to get the year, let's data.program.year. No big deal, right? Cool. Everyone's got that solid down pat? Okay, great. Any questions on objects? There's obviously more. Should I show you more right now, or just keep it simple? Let's just watch this guy. It's just 1 minute on JavaScript objects.
Demonstrate to you that it is more object-oriented than Java. For a long time, a lot of the opinion about this language was that it's not object-oriented, it's object-based, it's efficient. It turns out it's actually a superior language. So in this language, an object is a dynamic collection of properties. This is quite different than in most of the other object-oriented languages, which an object is an instance of a class, where a class has some state and behavior. Objects in this system are much more dynamic. So it's a collection of properties. Each property has a key string which is unique within that object. So if you add two properties with the same name, the second one will replace the first one. The fundamental operations for objects are get, set, and delete. This might be a fairly familiar pattern. So there are two pieces of syntax for doing get. You say object.name or object bracket an expression. And the two are completely
there, I'll pause it there. So that's something I want you to try. So let's try this. In your console log, let's try the other way of getting the code. So obviously you could do data.program.code, but he suggested there's another way using almost, I would call like an array kind of thing. And inside here, you could try saying data.program, and then in brackets, put the name of your property. Does that work? Try it. Does that work? Let's see. On your own. Work? Worked. Great. Okay. Another thing that he mentioned that I think I'll mention as well is you could set stuff and you can delete stuff. So let me just use this as a scratch pad. So let me just copy this code for now in my console. So now I got it. So data has everything, has the whole object. So to set something, let's say I wanted to change Georgian to something else. So can I change it? He said you could just do this, data.college. I believe that's what you said, Seneca. Now, if you look at your data object, so if I just say console log data, see. Okay. Cool. So that's how to set something. How about, okay, I'll throw this in. What if you want a totally brand new property? You could just, the answer is you could just declare it. So I'll say data. I don't know, country. I really don't. This is where, okay, so country equals Canada. Enter. Okay, so now if I say console log data, and I look at my object, is country there? How dynamic is that? Pretty good. That's what That's what makes this program dynamic. You just declare it to be so, and it is. Let's try deleting something. Let's try deleting the country. So he said, delete, in your code, you can say delete program.country, I think it was. Enter. Oh, hold on. Oh, sorry. Delete data.country is what I wanted. True. Okay. Console log data. On? Yeah. So that is your get, set, and delete. Cool? Everyone cool with objects? Next lesson. Okay. Fetch. So did you use fetch in the example? No, you did not. Okay. Remember last class when I asked you for the Kahoot game, I asked you to go here, api.github.com, and ask you what is that? And the answer was JSON, right? Okay. So GitHub offers this API service where if you say api.github.com/users/your GitHub name, so try it, you should get your info on GitHub. Try it on your browser. Try it. api.github.com/users/your GitHub username. API, yeah, so api.github.com/users/your username, okay? You should see your information on GitHub. So you should see your username, or login rather. You can see your avatar URL, where your picture is located. Different information. How many followers you have, things like that. Here's how it says that. I think you probably had a typo. API, HTTPS api.github.com/users with an S/. Yeah. Okay, now you see your JSON info, right? Cool. So I want you to just analyze the way this information is presented to you, syntax-wise, format-wise. What does this look like in JavaScript land? What did we just learn about? Looks like an object, right? JSON is an acronym for what? So this is JSON. What does JSON stand for? Yes, JavaScript Object Notation. So think about it. You can access GitHub information about yourself through GitHub's API website, get back a big, massive JSON of data, which then you can use at your disposal, at your whim, and do whatever you want with it. You can delete properties, add properties, use those get properties to display on a web page, right? Do you see the big picture, hopefully? Okay, so another way to think about it is this. In your programming career so far, what have you traditionally used to grab data? A database, MySQL. You send a MySQL query to a database to fetch the data in order to display the page. You can think of this as the new way to fetch data. You don't need a database anymore. Just go to an API website that spits out your data, grab the JSON data, which is like your query result, and use that programmatically. Right? Okay. So what did I say here? Store your data inside an array. Okay, so fetch. We're going to use this fetch thing. So yes, you could copy and paste this, but I prefer you type it in. So type this in, except use your GitHub username and see what happens in the console. Okay, let me try it on my end. Okay. It up. Oh. What do we get here? Oh, right. Okay, you probably all got this error message, right? Or this. It's not quite an error message, but you didn't get the data that you're expecting. You probably got this, yes? Show of hands, you got this. Object. Just object. Right? Like where's the data? What was it? What'd you get? You got the data? Okay, good. Then you did something extra. Did you have a variable before that statement? Before fetch statement, did you have a variable? No? You got the data as well? Okay, then what did I do wrong then? Oh, that's why. Okay, I was going nowhere with that. Save that. There we go. I got the data too. Great. All right, so you got the object. All right, cool. What I want you to do now is try to access our properties to display on the console. How are you going to do that? Here's how you're going to do that. What you need to know is this. Fetch returns something new in JavaScript land called a promise. So you can't just say, let's say if I say const my data, equals an empty array, and then over here, if you tried saying my data equals data, and then try console logging that data. So let me move this down here and say my data. Let me see what that does. I don't know what that's gonna do. I don't think it's gonna work. Oh, right. Assignment to, okay, here's your first test of what's happening. So this is saying assignment to a constant variable error. So what's wrong? How do I fix my code? What's the problem? Yeah, we haven't gone over const yet, but from other languages, constant, what does constant usually mean? You can't change it, right? So here I'm trying to change it and I can't change it. So I could say that it's let. Try that, refresh. Okay, that's cool. I guess that works. You could say that. That works. That's one way. Or you could push the data as well. So from here, now that I got my data as something, I could say console log my data dot, and then, well, I don't know, login, just to get the thing. I refresh, I just get the thing. Cool. So I just want you to take a couple minutes, play with that, try to get some values out of your GitHub user account, because in the next few moments, we're going to try to display your information on the web page. So just try getting the data on the console. That's all I want you to do. Just practice getting the data on the console.
Oh, there.
Let me just say, if you want to go ahead of the slides, you can go ahead of the slides and do it at your own pace right now, because I'm coming around helping a bunch of people, so I realize I can't keep up. So go ahead on your own, go ahead of the slides, and just work on your own pace on your back. Yeah, so this, yeah, good question. So, you see that? That is the weirdest error. Yeah. That's the weirdest non-error. Okay, let me just say what's happening here with fetch, because the question I was asked was this, like, what is this data coming from? Okay, so fetch, what happens is this. When you say fetch, and this gives you some data back, that data is not yet usable by you. It has to be transformed into JSON proper, because the JSON that you saw on API's website, in reality, that's just a string, like a big long string. It still has to be transformed, if you will, into a JSON, a JavaScript object. Okay, so the way it does that for fetch is you say a dot then, and this response, think of that like a blob of data, a blob of unusable, untransformed data. But as soon as you say .json on it, now it's usable by you. And that's why you say the next one. And this here is now the usable data. And so so I don't know if that kind of answers your question, but that data comes from the response above it, which is basically like a blob of data that was returned by fetch. I don't know if that answers your question. Yeah. There we are. Yeah, you're right. So in future cases, it's probably better to do it already. But in your case, I just wanted you to practice with fetch. To figure out the word of that. What problem were you using before? What browser were you using before? Chrome. Different edition didn't work in Chrome. What's up with that? I don't know. see if it's a JavaScript disabled, see if your font is scripts on Chrome, settings, or just use Firefox. Yeah. Any other questions? No? Okay, so let's move on. If you happen to be already moved on, that's great. Okay, the next thing I want to talk about is template literals. Template literals are the new way to write strings. Previously, you may have known that to write strings in JavaScript, you used which operator? Plus operator. But there's some disadvantages with using plus operator. So the new way is to use these backticks. Okay. So here's an example. You use the backtick, you put a string, done. But the cool part is this part here. So within those backticks, anywhere within those backticks, if you say $, squiggly bracket, variable name, and a squiggly bracket, it will insert whatever that variable is. And that's how to do it. Okay, so let's try that out. So let me just copy that out. Inspect, console, Control L, clears it. There it is. There it is. So the key takeaway is backticks in combination with these template literals, $, squiggly bracket. And inside here, by the way, it doesn't have to simply be a JavaScript variable. It could be any JavaScript expression, I guess. You could have like a function call, like capitalize name. And so you have a function called capitalize, it'll do it. Okay, cool. That's pretty simple. Here's a link I provided for CSS tricks to gain more about the new template literal. Another advantage to template literals over as opposed to the old plus is multi-line. So as you can see, you can actually press enter after the word B and it'll be multi-line. Whereas before you had to do some weird stuff in JavaScript. Check that link out if you have time. So try this. This is my challenge. Try saying my GitHub username is blank and use what you fetched. So this is your challenge. My GitHub username is blank. And insert what you just fetched. Let's see if this works. There. Okay, so here's my code to make it work. Again, yours could be different slightly, but the template literal stuff is this is what I was hoping you'd do. Is there any nested information? Cool. So everyone got something like that. So you just said console log backticks, and then use the $, squiggly bracket, and then your object. Cool. Easy, right? Easy peasy so far? Yeah. Okay. Let me just see what's the next one. All right. Sorry, Brad. I have to move on. But it's again. I'm recording this. Okay. Document.query selector. Let's just focus on this new thing. Document.query selector. Let me just show you something. So let's open up. I don't know, Georgian College webpage, whatever. Let's go to the console. Try this. Press in your console, just say the word document and enter. You can open up any web page. It doesn't matter which web page. Document, enter. Then you get this down arrow document. You click on that down arrow and what do you see? You see obviously the HTML code, right? No big deal. Okay, cool. The big takeaway I want you to know is this. Remember last class where I asked you to install that extension in VS Code called REST client, and then we could like go to any website and you could actually see what's transferred over the wire, where you can see the header and then the HTML code. Remember that? So the big takeaway is this. Whenever you visit any web server, what you get back for the response, in essence, is one big string, the header plus the HTML. Once it enters the browser, then it's interpreted. For the HTML side, it gets parsed into something called a DOM tree. So think of this. The browser, inside its brain, if you will, inside its memory, it actually has an upside down tree where the top is document. And everything else that stems from document are all these HTML tags. Which means for you, you have access to all these HTML tags. So I could say document, I could say document.body. It gives me just the body, for example. Now, for the slide here, document.querySelector, this allows you to search for any HTML tag. So if I just wanted one tag, for example, let's go back to here again. Let's say I just wanted the logo. So let me try to get this logo of Georgian. Inspect it. What is it? It has an ID of header image logo. Let me copy that. So in order for me to get that image tag, I'm going to do a document.querySelector, and I'm going to use this name, ID of header image logo. If this did not have an ID, I could use a class. If it didn't have either, I could just use maybe just, I don't know, some other CSS way to find it. But basically, the big takeaway is whatever is you put in query selector, think of it as CSS. You're using CSS way to get that. Okay, so let's try that out. In console, I'm going to say document.querySelector, and because it's an ID, I need the hash. Okay, enter, and I get it, right? So if I put my cursor over here, I actually got the logo, which means I can do stuff with that logo. I could distort it, I could delete it, I could whatever. Let's see here. Let's try doing it with a piece of heading. So instead of a logo, let's try something with just text. So let's try to get this one, this word academics. I'm going to try to change that word academics. So right click it, inspect it. Does this have any kind of ID or class that's unique to me? Not the A, but here, the LI does. It's using ID. So what I'm going to do is I'm going to do a query selector of this, followed by the A, which should get me the text inside A, which is academic. So I'm just going to copy this ID. I'm going to use that to my advantage. Go back here, say document.querySelector. Because it's an ID, I need a hash. Otherwise, I need a dot if it was a class. But I need the A after that. Right? Enter. I got the A. Let me put this in a variable because otherwise I can't do anything with it. So const, I don't know, A equals document. Same thing. A. Now A has that. Great. If I say, and this is on the slide, this one here, text content. If I say A.text content, that gets me academics. So if I say, this is just an object. If I say A.text content equals, there, it changed to Seneca. Cool. So try, let's see, what did I want you to do? Yeah. Okay, right. So this is where you try to put the data that you fetched onto the web page now. Okay, so let's try this. So fetch some data. Let's put in the body H1. Okay. We'll have it this time we'll use a class of okay. So what I want you to do now is I'll leave this up, but I'll leave it in I'll give you some pseudocode. So do a document query selector on the H1. I should say stored in a variable. Or it in a variable. Change that variable's content to your GitHub login name. Try that. That's your pseudocode. So instead of displaying the data you fetched into the console, we're going to try to now display it on the web page. Try that. Oh, I got undefined. What did I do wrong? My data. Oh, right. Ah, yes. Okay. There you go. I got caught with the asynchronous nature of JavaScript. Okay. Let me show you my mistake. Originally, I had this going on. It said, actually, I don't need this anymore. I'll just do that. So I said this document.query selector, and I wanted to get the H1 tag. And as you can see here, my H1 tag, I gave it a class of heading. So to get a class, not an ID, but a class, I have to use not the hashtag, but the dot for query selector. So that will get me the DOM element of H1, which means I can manipulate H1 now. So if I say h1.text content, I can put whatever text I want. So I said my data.login. But watch what happened when I saved that and I try to run it. I got nothing. And if I said console log my data, oops, I should get nothing. So what happened? And this is where I was trapped by the asynchronicity of JavaScript. Remember, this fetch takes a long time. It's like a panini in Tim Hortons, which means that, okay, this is delegated to the kitchen, if you will, which means that these quick ones, it'll have nothing yet. That's why it's undefined. How to fix that? Do you understand the problem? How to fix that? Yeah, from the kitchen. So let's move the whole thing. Boop, boop, boop. Save. So now, if I run it, no. Thing in the kitchen. As soon as you start putting delay on it just to force it to synchronize, you're playing with fire in JavaScript land. You are messing with fire. There's a better way to do it if that's your thinking. No. Okay. So that was a tricky one, but I hope some of you got that and understood why I got the undefined. And you will come across that in JavaScript land. You will understand why does this not work? Why isn't this showing? That's because you forgot about the asynchronous. Okay. Okay. What else did I say here? Yeah, cool. By the way, I put links here to MDN's web docs. This is the go-to reference for me, for a lot of web developers when it comes to JavaScript. You just say, MDN, Google MDN, and then whatever you're looking for, and it'll give you the documentation. Okay. Next. Okay, so this is one of the earlier questions. What's the deal with let and const? Why can't I use var? The reason is to deal with scoping. Okay. And I'm going to show you here an example. Let me see. Maybe, I think this one had a better example. Just see if this one had a better example. I was hoping to find the one with, yes, this is it. Okay. Here is the difference between let and var. So var is basically, you can think of var as it's scoped to almost anything. You could almost think of it as global, almost. For example, this console log of 2 is showing, and this console log of 2, because this var is overriding this var. Why? You would think that this var is actually scoped within this block, but the answer is JavaScript doesn't treat var that way. It treats let that way, but var actually escapes out of this block. So in essence, if you could imagine this var x being defined right underneath var x equals 1, that's how JavaScript compiles it. And then only here, when it reaches this line, it says x equals 2. Okay, because the scope of var escapes the squiggly brackets of the if. Whereas the let, when you say let, the scope of let is within that block only. And that makes sense to you. So according to this new way of doing things in JavaScript, according to this book, which is a very good reference book as well. Let me magnify it. Let me just show the cover of this book real quick. I gave this link to you on the announcements. So here's one website where you can get free ebooks. Here's JavaScript. This one here called Exploring ES6. Where's the let stuff? There it is. So he gives, the difference, and then he recommends, as well as TC39, they recommend this. My advice is this. For const, if you know the value will never change. Otherwise, use let, avoid using var. Okay. That is the majority opinion of JavaScript developers. There's one JavaScript developer that would disagree. His name is Kyle Simpson, who I also respect. But get to his level, then I understand why he would say this var is still useful. But so that's the way it is. So use const if you know the value will never change. Otherwise, use let and avoid using var. Okay, cool. Okay, inner HTML. It's sort of like text content, but instead of just inserting Seneca here, you can insert HTML tags along with Seneca, and it will display as an HTML rendered. Okay, so if I go back to, let's say, back here, I guess, go back to my Seneca thing. Let's do a refresh here. Refresh. Or L to clear that. So I'm going to try to insert maybe a heading, an H1 tag before this logo. Let's try that. Let's just see what happens for kicks. So inspect logo. ID equals that. Okay, so I'm going to use that to my advantage. I'm going to say document const image equals document dot query selector found that my image should contain that. What if I replace? Oh, I know. What if I replaced the whole image, and inside the image tag I'll have like an actually can I do image text content? Is that even possible? I don't know. Try it. Or inner HTML equals. Oh, let's try if this works. I don't even know if this works. You know, that work? No, it didn't work. I think I need a text, not an image element. Try something else. Say, let's use the blank page I had before. So here I had the heading. So instead of saying my data.login, which will give me the thing, what if I added some HTML code? So backticks, and inside of this will be the template literal, because that's a variable. And we'll say h1, and here's h1. Let me try that. Oh, it'll be like two h1. Actually, hold on. It'll be like two h. That'll be weird. Yeah, it'll be embedded h1s. Yeah. Oh, right. Hold on. I'm using text content. What if I said HTML? And you should have there. So if I inspect that, it should be like embedded h1s. Yeah. See. Okay. You get my drift. Okay. But the big takeaway is this. The big takeaway is this. So not only can you insert text content, but you're telling me I can insert HTML code. Okay. So for something like this, take some CSS framework that I've worked with in the past. Here's a CSS framework that you can download and edit to your desire. This here is a component. So if I inspect this and look for there, this div tag class email item is responsible for this whole thing, right? And similarly, all of these others are similar components. So with inner HTML, imagine this. In my JavaScript code, I can write this exact div, you know, this HTML stuff that makes this one component, have it loop to produce basically an entire list of emails. That's the big takeaway. So no longer are you writing HTML in HTML. You are now writing HTML in JS land and having JavaScript output the HTML for you. That's the big takeaway. Okay. What time are we? 1:22. Oh my goodness. Okay, and it's still not done yet. I'll just quickly go through this. Okay, add event listener. This allows you to bind events to certain things. So for example, if I have a button, let's add a button right here. Button tab. Let's say click me. Okay. So if I save that, if I refresh it, where's my thing? Here's my button. Click me. It does nothing as expected. But let's make it do something. How do you make it do something? You need an add event listener. So add an event listener. First, you have to get the thing. So let's say const button equals document dot query selector. In this case, I don't have a class or an ID. That's okay. I'll just use regular CSS stuff. And because that's the only button I have, I'll just say button. We'll get it. Let's just test that theory. So I'm going to console log the button just to see if I got it. Okay. Fresh console. There it is. Button. I have too much console going on here. Let me just. Where's my other console here? Let me get rid of this. Save. Refresh. All right. So I got the button. Great. Let's do something with that button. I want it to respond to a click. How to do that? So now you say button.add event listener. In brackets, you say what you're looking for. You're looking for a click. So anytime this button is clicked upon, it will do the following to-do list. is where the callback function comes in. We'll say console log I'm clicked, or just say clicked. Okay, so anytime it's clicked on the console, you'll see it's clicked. Let's try that. Refresh, click, 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 click. You can see it's enumerating there. Okay, so that means you could do anything you want in here. You know, you could say if it's clicked, change the heading from whatever it is to something new. You know, if it's clicked, add a new H1 tag just below it, kind of thing. It's, you know, your imagination is your the sky's the limit, right? Okay, that was that. And by the way, click is not just the only event listener. There are others. For example, you can listen for a key press, for example, and there's others. And I've provided a link here for you. Okay, arrow functions. The way to explain arrow functions is this. It's just a shorthand notation, just like acronyms. You know, acronyms are a shorthand for longer names. Arrow functions are just a shorthand notation for the same thing. So here in the example I have that comes from this link, let's take a look at the documentation. This here is an arrow function. And I'm just going to write down real quick here, just a simple way to do it. So here's the traditional arrow. Here's the traditional function, for example. You get some argument, you know, and you can return. So here is a traditional function. An arrow function does the exact same thing, except it's less verbose. So to do the exact same thing here, you just get rid of the word function. You have name there, arrow, and then you get rid of the word return too, and that's essentially it. So this is what you would write as an arrow function, which is equivalent to this one above. However, there are some rules. The rule is if there's only one parameter, you actually don't need round brackets. The rule is if there's more than one parameter, then you need the round brackets. The rule is if there's more than one line of code, you know, then you need the squiggly brackets. That's basically it. It's just a shorthand notation. Okay. Trying to get quickly done here. Where's my slides? Let me just see this documentation real quick. Just anything else I'm missing? Here they have an example here. Inside .map, they put an arrow function. So this material is your single parameter, right? Inside the brackets, the round brackets. And this is your return statement. I'm returning the length of that. Let me see what else is there. Another better example. Yeah, that's it for now. That's it for now. I don't want to confuse you. So just think of arrow functions that are like shorthand notation. Okay? You just have to get used to how it looks. Otherwise, it functions the same way. There is one caveat to arrow functions I should mention, and I don't want to pile stuff on you, but I'll just say this: if you're going to use the word "this" inside your arrow function, you may not want to. You may want to consider using the traditional function. And I won't say why now. It'll just bug you. We're going to try this. We're going to try some array methods right now. So I've provided some links here. So let's try this first one, push array.push. Actually, let me just get a show of hands. Show of hands, who knows about push from other languages and are familiar with pushing stuff in an array? Yeah? I mean, you've never pushed any stuff in an array before? Okay. 130. Okay. I'll just show this based on the documentation. Although ideally, I would have liked you to type it out just to get practice. We're running out of time. So here's an array, right? Simple. Y'all know about arrays. If you say dot push and inside the brackets, whatever you want, it'll add that cows to the end of the array. As you can see here. So animals dot push cows, console log animals. The output is this. Simple? Yes? Simple. Great. The big takeaway I want you to imagine right now is a lot of code that in JavaScript land you'll see is an array not of simple things like strings, but more complex things like an array of objects. Think about that. Okay. What else do we got here? We got, where'd my slides go? We got filter. Filter is a new thing in ES6. Check it out. So you have an array of words. Okay, and I in this example, I only want words that are larger than 6 characters. So you have this words dot filter, and you pass in the test case here. Okay, so this is an arrow function. So what is this? This is the parameters normally inside the round brackets, right? Normally you'd have the word function here, followed by the round brackets, followed by the word inside those round brackets. Then the body of the thing is, this would normally be return only those that have greater than 6 characters. And so the output is just this. Yeah, does that make sense? Cool. Okay. Again, I wish I had more time to for you to practice this, but just for now, just knowing about it is good enough. Okay. There's a reason I'm going through all of this, and it's because of your lab. Okay, here we go. Now the next one is the map. This, out of all the array functions or methods, this is the most important. Map. This is by far used a lot in JavaScript land. Let's run this just to see what it does. Right. So what's happening here is .map will look at each individual element in the array, and that's represented here. And then what it will do, it'll do something to it. So in this case, it multiplies each element by 2. So you get the array of everything multiplied by 2. The way to think about the .map, which I've heard, is think of this. You have the same set of inputs. So you have, let's say, 5 inputs going to .map. You have 5 outputs as well. So there's a one-to-one correspondence for .map. The only difference is something has changed. Okay. Whereas filter could be 5, but it could be less than that, depending on your test case. Right. Cool. And what is this one? The spread operator, which is kind of neat. Oh, why am I getting some other language? That's so weird. No. Oh. Okay, so here's the big idea. You have an array. You say ... of that array. It takes each individual element and spreads it out. That's why it's called the spread operator for you, so you don't have to do the hard case of flattening the array more. Kind of. I think the example in the West Boss video with the LinkedIn video where he was spreading, what was he spreading? He was spreading the, I forget what he's spreading, but it essentially flattens out the array for you, kind of thing. Let me see if there's a better example here.
Is it one dot per element?
No, it's just ... It's not. The number of dots has nothing to do with it. There's a better example here somewhere. Oh yeah, perfect. Okay, this is a wonderful example. So here, Parts is an array of two things, two elements in the array. Lyrics, check this out. You could say your elements, your traditional elements, but you could say dot, dot, dot parts, and it flattens out whatever's in that array for you in that new array. Cool? Is that cool? That's cool too. I've never seen that before. Before ES6, I've never seen that. That's cool. So that's what you need to know. Am I done? Yes, I'm done, finally. Okay, great, 134. So in summary, JavaScript has matured due to a lot of different things. Ajax. I mentioned Gmail and Google Maps only because when I was growing up, the internet to me was just like Wikipedia. Right? Click, refresh. Whereas the first thing that I saw that boggled my mind, like how did they do that, was Google Maps. When I first saw Google Maps where you could drag the map, I said, how did they do that without a refresh? Then along came jQuery. I will say this about jQuery. jQuery came along at a good time because JavaScript was not very pleasant to work with back in the day. jQuery made JavaScript better to work with, but it also forced JavaScript to be a better language. And that's why we have ES6. Then Node came along, V8, ES6. So yeah, web development has changed pretty quickly within the last few years. More and more of the logic is moved from the server side to the client side. So for example, I just mentioned, instead of having the HTML code being spit out from a PHP server, you now have HTML code being spit out from your own browser through the JavaScript. That's what's happening. And so when you hear the buzz terms today of Angular, React, and Vue, that's all client side spitting out HTML. See? So Angular, React, and Vue, they can get the JSON data from GitHub, for example, form some HTML code inside the browser, spit it out on your browser at the same time. That's what's happening. And yeah, so you learned some ES6 stuff and references. So the lab for you, any questions so far? Any questions or comments? I know it was a really information heavy day today. Yeah, I can feel it, right? The lab I have for you today is a fun one. The original lab that was on here, I thought it was a little bit too simple. It was just like do something with an array. So I've upped it, but it's fun. So under assignments, under lab 2, I've given you this index.zip file. So if you unzip that file, you'll have one file, index.html file in there. I'm going to ask you to watch this 17-minute video. It is the same guy who did the LinkedIn, and he's going to show you, and you just basically code along with him, okay? I think there is value for you just typing your way through the JavaScript code, even though you're just copying exactly what he's doing. There is value in just typing away, okay? So I want you to just type away, and once you're done finishing the code, you can upload it to GitHub. You can upload it to DreamHost as well, and submit both your GitHub link and your DreamHost link as well. Now,
I thought we were supposed to do GitHub or DreamHost.
Oh, sorry, it's both GitHub and DreamHost. Okay. Now it doesn't have to be DreamHost; it could be something other. Okay. Now, if you just do that, the maximum mark you can get is 80%. So 2 out of 2.5. So I'm giving you an incentive to go further. Here's your bonus challenge. If you want more marks than 2 out of 2.5, then I want you to change the endpoint from what it is to this new one. Okay, so just like how I asked you to fetch from GitHub to get some JSON data, I'm going to ask you to, after you've coded along and after you finish your code, I want you to change the endpoint, change the API, whatever he had in his code, change it to this new one, which is going to give you a whole bunch of different JSON data. And then you have to edit your code to try to make it work. Okay, so if you get it working, you get 5 out of 2.5. If you don't get it working, I'll still give you more than 2 out of 2.5, depending how far you get, how far you get in the code. Okay, so, and I've changed the due date. So usually I said labs are due Friday at midnight. I think this will take a little longer. So I've given you till Monday at midnight for this. And I've switched up the quiz. So the quiz 2 will be due tomorrow at midnight. So which means I'll have to make up the questions and put it up. But yeah, okay. Cool. Done. Any questions, comments? Okay.